Hello everyone. In this lecture we are going to discuss about implicants, prime implicants and essential prime implicants. So we use these three terms when we minimize Boolean functions using kernel maps. So let's see how we can use these different terms and what they mean. So the first thing is we look at is implicants. So what is an implicant? So an implicant, by an implicant we mean any groups of ones that we can form. So groups of ones. Now not just any grouping, so we know we have to follow 2 to the power some value n, so power of 2 groups. So that means I can have groups of single ones, that is 2 to the power 0. I can have groups of 2 ones, which is 2 to the power 1. I can have groups of 4 ones, which is 2 to the power 2. Then 8, 16 and so on. So in this particular example that we have here, kernel map, so we can see that how many, first let's see how many of single ones we have. Single ones, see, single ones. So single ones we have here, let me mark it with red. So 1, 2, 3, 4 and 5. So each of this is an implicant. So I can write it as here I have this first one is x dash y dash z dash. Then the second one is x dash y dash z. Then the third one is x y dash z dash. Then we have x y z, and then we have x y z dash. So each of this is an implicant. Now let us see how we can form groups of 2 next with these. Can we have groups of 2s? Yes, we can have this group, we can have this group, we can have this group. Also we can have these two as a single group. Okay, so we will add these to our list of implicants. So we have for the first green, that is x dash and y dash, x dash y dash. Then we have for this vertical group, we have y dash z dash. Okay, then for this group of 2 we have x y, and finally for this corner ones, group of 2s with corner 1, so we have x and we have z dash. So we have from the groups of 2s we got this. Now can we form groups of 3? We cannot. So this is the largest group that we can form, groups of 2s. So all of these are now your implicants. So this is your group of implicants. Okay, now next let us see about prime implicants. Prime implicants. So for the same example that we have seen here, we saw that we can have all these groups of ones. So the implicants are basically the groups of ones. So maybe single one. So all the mean terms will appear. Like you can see, all the mean terms have appeared. We have 5 mean terms, all the 5 mean terms, and then groups of 2s. We got these 4 terms for the groups of 2s. Now we will take those groups which forms the largest in the largest group of ones. That is, I have uh, x and y and z. So I had this is what I had. So the groups of largest group of ones that I can have is of size 2. So which are the groups? One is this red group, then we have the green group here, okay, then we have this group. All of these are groups of 2's. Then we also have this group. So all these groups, the largest groups of ones that you can have, they form your prime implicants. So prime implicant is nothing but it is the largest groups of ones. So in our example here now I have for the red one, for the red group I have x dash and here I have y dash. For the blue one I have, for the blue group I have x is not there. You have y dash z dash. For the green group I have x and y. And lastly for the purple group I have x and z dash. So these four are your prime implicants. Okay. Now out of these, not all will become your essential prime implicant. So what is an essential prime implicant? So if you see here, let me just remove this. So we want to find our essential prime implicants. So these are our prime implicants. Out of these, some of these will be your essential prime implicants. So essential prime implicants will be the ones which appear only in one group. So if you see, let me use a different color. So let me pick, okay, yellow. So if you see, this one appears in two groups, the red group as well as in the blue group. So we will keep this as it is. Let's look at the next one. This appears in only one group, that is the red group. So this will be our essential prime implicant, okay, because it appears in only one group. So the group to which this one belongs will be our essential prime implicant. Similarly, the blue one here, okay, here this in the blue group we have this one which again appears in more than one, and also this one which appears in more than one. So this is not a essential prime implicant. Similarly, let us take the green group. Now here this one appears in only one group, so it is the green group now is an essential prime implicant. Okay. What about the purple group? The ones in the purple group, see here, this one appears in two groups. It appears in the red group as well as in the purple group. Similarly, the one here appears in the purple group as well as in the blue group. So these two, that is the purple group and the blue group, these are not essential prime implicants. So our essential prime implicants are the ones which is the red group here and the ones in the green group. So these two are essential prime implicants. So we have seen our implicants. We have our implicants here. So this whole group is our implicants group. Out of this we saw that this subset is our prime implicants. Okay, and then out of this prime implicants, so this is our prime implicant group. Out of these prime implicants, these two, they form the essential prime implicants. So you can say that essential prime implicants are the prime implicants that appear in only one group of ones. So you can have a kind of a subset, a kind of a drawing. So first of all, you have implicants. Some of the implicants are your prime implicants, and some of the prime implicants are your essential prime implicants. Okay, so what is the use of these implicants, prime implicants, and essential prime implicants in the minimization? So when you try to minimize a Boolean function using Kernel map, in the minimize function, minimized Boolean expression or Boolean function, essential prime implicants will always be there. Will always appear. But they will not be the only terms in the function. So the prime implicants will also appear, okay, but not all. Not all prime implicants. If we just go back, we can see here. So you see, these four are the prime implicants. Now all of these, out of these, this is the essential prime implicants, this is the essential prime implicants. So both of these will appear. Now the remaining ones, that is this x, y dash, z dash, and x, y, z. Now are these two, see, they overlap. So you can either keep one of these. So out of these two, you have a choice. You can keep either y dash, z dash, or you can keep x, z dash, because they can be combined together. They can be combined together. So you can see, you can either keep y dash, z dash, or you can keep x, z dash. So let us see which one we want to keep. We can keep any one. So my minimized function f would be the essential prime implicants, which is x dash, y dash plus xy, x dash, y dash plus xy, plus one of the prime implicants of this. So I can keep y dash, z dash, or I can write the same function again minimized with the essential prime implicants, and the next one, that is x, z dash, x, z dash. So both of these are minimized function for our Boolean expression. So essential prime implicants will always appear, and from the remaining prime implicants you can choose.